So how can we compute a random value in a specific range using Java standard library? Well, first of all, let's just do a quick demonstration of what is available. I'll create a loop, a for loop, which I will use count. And let me start with 0 and go, perhaps run it 10 times. So we'll say less than 10. And increment count. So we have a simple variable to control number of iterations in this loop. And what I'd like to do is just print. I'll print it on a single line like this. I'll print the values from math random call. So math random is a method that is built in math Java library, and it returns a number in range from 0 to 1. Because it returns back a fractional number. So this is the focus of the random number generator here. So it just returns a fractional number. So actually, let's print this on the next line so that we don't have to obscure anything within the parentheses. So just going to temporarily comment out the unfinished version of the call to get random, and just want to display the results of these math random calls. Okay, so when I run it, you see that these are kind of ugly looking fractional numbers, but they're all in range from 0 to 1. Okay, so every time we run it, we will see a different set of these numbers being generated for us, and you can see that they're differing as we run them. So this is one of the possibilities to generate this random number, and if I want to convert this random number into an integer, what I would have to do is just simply I need because it's in range from 0 to 1, if I convert it to an int, right, I can use the casting operator and say I want to take this result of a random, which is actually a double value, double precision floating point number, and cast it to an int. So then if I run it, it just all becomes 0 because this casting simply removes the fractional part from this floating point number, and it makes it all 0. So this is not a very successful way of doing it. However, if I kind of before I make a conversion to an integer, if I amplify it a little bit, so I can, for instance, multiply by 10. Okay, and if I run it this time, it actually didn't work because the conversion to an integer took place before my amplification. So I need to parenthesize this and try it again. Okay, so like this. With this new version of the program. So you see that this time I'm pretty much getting something that looks like the random number, which is an integer that we want, and it's in range from 0 to 10. So you see that there's like 4 and 1 and 3 and 9 included there. So if we keep running these examples, you see that we're getting, and 0 is also included. So this is a way to convert this original random fractional number in range from 0 to 1 to an integer. So first we amplify it by multiplying by some sort of maximum range number that we want, and we convert it to an integer, and we do it 10 times so we can see the sampling of multiple values of doing this. So we can kind of rely on this idea to implement our function. So I think that what we can do, we can just basically take this and decide that in case if we want to get random integer in range from 2, and we want to include this range in the generated numbers, then first of all we need to decide what is the actual maximum range. So we'll say, okay, we can compute it as an integer that we can call max num, right, maximum number, and it would equal the upper bound, right? So like for instance 10 when we call random int. So this will be the upper bound minus the lower bound, okay? And we also need to add 1 if we want to include both. So if we want our random numbers from 5 to 10, then we have to add 1 right here. Okay, so to increase the range, because the 10 here was excluded, we need to add 1. There's always a little bit like with ranges, there's always a little bit of a boundary issues with like +1, -1. You really have to tweak your code to make sure that your boundaries are processed correctly. There's always a little bit of concern on the boundary when you deal with ranges. Anyways, this is just a number like 10 by which we're going to amplify this fractional result. So instead of random times 10, what I'm going to do is this max num, right? So we're just going to do the max num. We are going to use the parentheses, and we're going to cast this amplified fractional number to an integer. And once we cast it to an integer, we can return it back from our method. Okay, so I will modify this loop right now to actually start using our own version of random number generator. So I'm just going to sort of move this inside my loop. So this I use for our initial reference, and copy and paste this here. Okay, so this will be our integer random number, and so let's use 5 to 10 and print the result. Okay, so because we're printing on new line, I'm not going to use these decorations anymore. Just print a random number on a new line. So let's take a look at this and run it. So you can see that because we're amplifying a small fraction in range from 0 to 1, so it's less than 1, by our maximum number, the result that we get here is within really the maximum number range. So in order to be able to shift this into the range that we like between 5 and 10, what we need to do is that we need to add this lower bound value to the result. So we need to essentially add this like this. So actually I prefer to add it in front so that it's the lower bound plus whatever, right? So basically start using it as a foundation value plus whatever the randomness is going to give us to range from 2. Okay, and this is the maximum number by which we amplify the original value. So this recipe should work pretty well. So I'm expecting that if we're going to run this a few times like this, you begin to observe that what I'm getting is like 5 is included here, 10 is included here, and these are the random numbers that I get. Okay, so this is an example of this sort of a, again, going back to the idea that we have this typical method that computes some sort of value using formulas and then returns the result. So I did not create a separate variable. I just I could even use this computation without creating of this integer number. So sometimes these formulas could look a little bit obscure. So sometimes it helps to break them down to multiple steps. It really does not affect any efficiency of our code, but makes the code a little bit more readable, and we have a chance to document it a little bit more. But anyway, this is one of the solutions that are possible using math random to be able to produce this desired random number in this specific range.